Hello class, and welcome to today's lecture over stats. Today, we're going to do an intro to stats for AP Biology. Now guys, for this PowerPoint, there is no separate note outline that you guys have to fill in, but there are available two student note handouts that kind of go over standard deviation and standard error of the mean. Now today though, we're going to just do standard deviation. This is going to be lecture part 1, standard deviation. So guys, let's go ahead and get right into it. So guys, stats, what do we use it for? Why is it useful when it comes to biology? Well, statistical analysis is used to collect a sample size of data, which can infer what is occurring in the general population. For example, let's say in biology, we're studying killer whales. It would be nearly impossible to study every single killer whale that's on this planet. But what we could do is take a sample size of 100, study that sample size of 100, use statistics to kind of tell us what's happening in the entire population of killer whales. So notice how it's really practical for a lot of biological studies. Now, guys, stats does require some math skills and some graphing skills. So hopefully you're going to bring those. And I know, guys, you have great graphing skills already, math skills, we've practiced those. Now, when we study a lot of different types of data sets, a lot of different populations, or just general data, we usually see what we call a normal distribution or a bell-shaped curve range of our data. Guys, a good example of this is when I give you exam data. Guys, a lot of the exam data that I give you for most classes always usually shows a normal distribution, a bell-shaped curve, which kind of looks like this, where let's say for an exam, the average is about an 80. Well, usually that means that most of the students are usually close to that average of an 80, but then you always have outliers, those that do really well on the exam and then those that kind of don't do so well. We see this usually in a lot of population studies or just studies when it comes to biology, where once again, a lot of the data points usually are going to be centered around a mean and average, but then you're going to have outliers, those that kind of like are extreme on one side and then those that are extreme on the other side. Now, when looking at statistics, there's two important considerations. The first one deals with what we're going to talk about today, standard deviation, and that is how much variation do I expect in my data? When we collect data, am I going to expect my data to be really spread out away from the average, or is the data going to be more concentrated near the average or a mean? So that's what we're going to focus on today. That's kind of standard deviation. The other consideration we'll talk about in lecture 2 is how does a sample and true mean differ from each other, and what does that tell us about the data? Usually the sample mean is the mean that we figure out. Let's say we're studying a population of killer whales and we're studying a population of 100, and let's say we're studying the mass. Well, the sample mean would be the mass, just that 100 population of killer whales that we're studying. A true mean would be if we were to go out there and take the mass of every single killer whale on this planet. That would be a true mean. So standard error of the mean is going to kind of tell us about that information. But that's for another lecture. Today, we're going to look at standard deviation. Now, before we start talking about standard deviation, there's some terminology that we need to make sure that we understand and know how to calculate. First of all, mean. I think most of you know what mean is. That's just the average of the data set. Median, that might be new for some of you. Median is the middle value of your data set. Usually what you have to do is put all your data in numerical order, and then it's the number smack in the middle of your data set. Mode is the most common value of your data set. It's the one that you see most often in your data set, or that's repeated the most often. So let's go ahead and go over a simple example. So mean, average. Guys, I think all of you know how to calculate an average. You add up all the numbers and then divide by how many numbers you added together. This is kind of our fancy equation. But let's look at an example. Let's say we have these 5 numbers, 3, 4, 5, 6, and 7. I ask you to figure out the mean. What do? You add up all the numbers, get 25, divide by how many numbers you had, 5, your mean is 5. Pretty easy, nothing to it. What about median and mode? Well, guys, median, once again, it's a number smack in the middle of your range of data. First, though, you have to put all your data in numerical order, and then it's the number right in the middle. Now, if there is no true number right in the middle, let's say you have an even number of data points, what you do is you get the 2 numbers in the middle and average them out. Mode, once again, that is the value that repeats most often, that appears the most often. So let's say we have this data set, 1, 6, 4, 13, 9, 10, 6, 3, and 19. Guys, let's do mode first. Which numbers repeated the most? Give you a second to think about that. Hopefully you said 6. 6 repeats the most. Now, what about median? Well, that's a little bit trickier. First, you have to put them in numerical order. So we have 1, 3, 4, 6, 6, 9, 10, 13, 19. Guys, let's get the number right in the middle. And I think that number right in the middle is 6. Notice we have 4 numbers on this side, 4 numbers on that side. 6 is going to be our median. We talked about how our mode is also 6 as well. So guys, nothing to this. That's pretty easy. However, now let's talk about standard deviation. And once again, standard deviation just tells us how spread out our data is from the mean. That's pretty much our definition of it. However, there is this rule that we're going to talk about called the 68, 95, 99 rule. And what that tells us when it comes to standard deviation, it's also going to tell us something about standard error of the mean. But right now, we're focused on standard deviation, is that in normal distribution, about 68% of the values are going to be within one standard deviation away from the mean. And usually the way we report this is in terms of a plus or minus standard deviation. So it's pretty much telling us how much variation there is from the mean. So at one standard deviation, that would tell us that 68% of our data is going to be one standard deviation away from the mean. Now, when you look at your data, if you have data points that are really close together, that's already going to tell you that your standard deviation is going to be pretty small. If you're looking at your data points, they're really spread out, you're already going to have an inclination of like, oh, my standard deviation is going to be pretty large. So let's look at this 68, 95, 99 rule. So let's say we're studying some data. Let's say this is exam data. And let's say the average of this exam data is a 75. So let's say right here we have 75. That's the mean for this recent exam that maybe my students took. And let's say we figured out the standard deviation is 5. We'll actually work out a problem next on how to figure out standard deviation. But let's say I just tell you, oh, standard deviation is 5. So what we do is we do our 75 and do plus 5 and minus 5. So 75 plus 5 is 80. So this line right here would be 80. 75 minus 5 would be 70. So this line would be 70. That's our range from 70, 80 is one standard deviation away. So I would say 68% of my students got between a 70 and an 80 on this most recent exam. That's what one standard deviation is telling us. What about 2 standard deviation away? Well, 2 standard deviations away tell us that 95% of our data will be 2 standard deviations away from the mean. So if my standard deviation was 5, but now I want 2 standard deviations, all I have to do is double my 5. 5 plus 5 is 10. So now what I do is if my mean is 75, I add 10, so that's 85. I subtract 10, now that's 75. So my range is 75 to 85. So now I could say 95% of my students got between 75 and an 85 on this exam. Now, if I wanted 3 standard deviations, that tells me 99% of my data will fit 3 standard deviations away. I would triple my standard deviation. That's 5 times 3, 15. So you're going to do 75 plus 15, 75 minus 15, and that's your new range. And that tells you 99% of your students fall within that grade range. So, guys, there's a cool little Bozeman video that I'm going to put on the Wakelet site that you can look at to kind of go over standard deviation if you're still having trouble. But hopefully, you guys are understanding so far. Now, let's talk about how you actually figure it out. Well, the first thing we have to do, let's look at the equation. Guys, no need to memorize this equation. It's always going to be given to you. S stands for standard deviation. We have square root. We have this symbol, sigma. That shouldn't be weird to you. We've studied that symbol before when we did chi-square. That means sum of. X is a data point, so that could be a killer well, that could be an individual grade, minus X with a little bar. X with a little bar means mean. That is your average. Then you're going to square it. So you're going to get every single data point. You're going to subtract it from the mean. You're going to square it. Then you're going to take the sum of all those numbers, divide by n minus 1. What is n? N is your population size. So it's how many grades you had. Maybe it's how many killer whales you studied. It's the entire data set that you have minus 1. Then you have to take the square root, and that's going to give you standard deviation. So guys, the best way to really get to know standard deviation is to practice. So let's do a practice problem. And guys, I'm going to go and look at grades again. So let's say this recent quiz you guys took. I I have 175 students. That's a lot of students to do kind of this information. So I'm going to pull just one class. So let's do it. I do a sample size. And I pull out a class of 10 students, and these are their grades. They have a 96, 96, 93, 90, 88, 86, 86, 84, 80, and 70. So pretty good on this quiz. But I want to know, how spread out is this data? What percentage of my students got around this one standard deviation, two standard, three standard deviations away? So the way I like to do my standard deviations, I like to always set up a table. Now, there's different ways of doing this. You can do it your own way. I'm going to show you how I do it. So first thing I do is I record every single one of my grades. So I have 10 grades, so I just put them on here: 96, 96, 92, 90, 88, 86, and so forth. First thing I want to do, I want to figure out the mean. So what I do is I add up all these numbers, and I got 868, and I divide by how many numbers, how many grades do I have? 10. So 868 divided by 10, boom, 87, that's my mean. Pretty easy. Guys, go ahead and check my math. Calculate this. Hopefully you get 87 as well. And you should. I don't think I made a mistake. So next step, notice I have my mean. Now I need to subtract every single one of my grades from the mean. So what I do is 96 minus 87, boom, that's 9. 96 minus 87, that's another 9. 92 minus 87, that's a 5. 90 minus 87, that's a 3. 88 minus 87, that's easy, that's 1, and so forth. You're going to do that for every single one of these numbers. Don't worry about the negative numbers. They're going to go away in our next step. So notice our next step is we subtracted every single number. Notice our next step, we square our number now. We've already subtracted, so we're going to square every single one of them. So 9 squared, boom, 81. Another 9 squared, boom, 81. 5 squared, 25. 3 squared, 9. 1 squared, 1. Notice you square a negative number, boom, positive. It goes away to 1. So you square every single one of the numbers. Then what you do is this symbol. Don't forget, you have to take the sum. So we square them. So now we're going to take we're going to add every single one of these, and we get a total of 546. So we have our total. Now we're going to take the square root, but before we take that, sorry, my bad, I spoke a little bit too soon. We need to actually divide this 546 minus n minus 1. So let's go ahead and look at that. So what is our n? That tells us how many grades. How many grades that we had? We had 10 grades. So 10 minus 1 equals 9. So what I'm going to do is 546 divided by 9, and then I take the square root of that. So here's our standard deviation, square root of 546 divided by 9. That gives us 7.79. I'm going to round to the nearest whole number, 8. So our standard deviation is 8. Guys, that's awesome. We got our standard deviation. That's a lot of work. It takes time, but was anything of it very complicated? I don't think so. I think it's pretty easy. Just take some time. But now let's apply what we really need to know. What does that 8 tell us? Okay, well, let's go back. Guys, our mean for our grades for this exam was an 87 of our sample size. So the mean was 87. Our standard deviation was 8. So that tells us that at one standard deviation plus or minus 8 from the mean of 87 is where 68% of our population or 68% of my students would fall within that range. So what we would do is we get at one standard deviation, we get our mean 87, we subtract 8, we get our mean 87, we add 8, and that gives us a range between 81 and 95. So standard deviation would tell us that 68% of my students got a grade between 81 and 95. That's what our standard deviation is. That's how spread out the data is. 68% of my students got between 81 and 95. That's one standard deviation away. What if I wanted 2 standard deviations away? What if I want to know where 95% of my students kind of lie? Well, what I do at 2 standard deviations away, if my standard deviation is 8 and I want 2 standard deviations, well, all I have to do is multiply it or just double it. 8 plus 8 is 16. So now I get my mean of 87, I subtract 16, I get my mean of 87, add 16, and that gives me a range now of 71 to 103. So at 2 standard deviations away, that tells me that 95% of my students earn between 71 and a 103. Guys, what if I wanted 3 standard deviations away. Well, standard deviation is 8, so now I multiply it times 3, that's 24. So now 87 is my mean minus 24. 87, which is my mean, plus 24, that gives me a grade range of 63 to 111. So that tells me that 99% of my students got between a 63 and 111. So that's what standard deviation is telling us. Guys, I hope you understood this. Hopefully, guys, this wasn't too confusing. Guys, this is where this lecture is going to end for today. This is just standard deviation. Guys, go and work out your standard deviation problem set number 1. Guys, I'm going to have another Zoom meeting to work out. I'm going to have a Zoom meeting for that to work out that problem for those of you who are having trouble. Guys, make sure you check out the Wakelet site. I'll put some Bozeman videos there if you're still having trouble with this, or guys, request some help. Guys, we could always do a Zoom tutoring if you're having an issue, and I could work through these problems with you. So that's it. Hopefully, you know now a little bit more about standard deviation. Once again, telling us how spread out our data is. Don't forget the 68, 95, 99 rule. That's essential for standard deviation. It's also going to be essential for standard error of the mean. Well, guys, before I leave, once again, check your Edmodo Daily, check your Wakelet course site as well. And that's it. Guys, go ahead and have yourself an awesome day today.